Hey guys, so I'm going to make a little video on demystifying slope. So you hear a lot of times this idea that slope is rise over run. But what the heck does that even mean? Well, okay. It's all about a basic line. And it can get more complex than this, but really we're just looking at lines. So this is a line, right? A line is defined between 2 points. So I could have, say, a point here and a point here. And that way I have, bloop, a line. It can go off for infinity, or it can have set endpoints, or it can, it can be a ray and it goes off all in just one direction, whatever. But the big thing here is that slope is actually really, really important for a lot of what we do with lines. Lines are ways that we can make sense of the world, make sense of data that we observe and tabulate, collect based off of what we see in the world or what we predict could happen. So, a lot of applications for lines. Super important that you understand slope. Slope basically is talking about steepness. So, this line has a slope. This line has a slope. Okay. This line has a slope. They all have literally a certain rise. Zoop. There's a rise. There's a rise. There's a rise. Over a run. There's a run. There's a run. There's a run. And so you can think of these in terms of angles, like, yep, there's an angle, there's an angle, there's an angle. And the steeper they are, like imagine it's harder for you to climb up, or maybe you'll fall down faster if it's a slide. The steeper they are, the greater the slope. You look up a hill, you're like, look at that hill down yonder. That thing's got a pretty large slope. All right. Or if you get a little teeny rise in the horizon, you say, that's a mite little slope there. Okay. Maybe I'm really not doing too good on my accents, but you get the idea. So, how do we define all these things? How do we deal with these? Well, a lot of times in mathematics, they define it based off of a coordinate system. So, we'll have something like this. It's not perfect, but it doesn't really matter, right? You have a coordinate system. And a lot of times we use quadrants. We say like 1, 2, 3, 4. It could be in the opposite direction, but we usually go counterclockwise. 1, 2, 3, 4. And a lot of times you really just focus on these two. Okay, so this section. It's the beauty of MS Paint, y'all. Okay, so this is quadrant 1. It's the positive section. Everything up here we consider positives. That's positive horizontally, positive vertically. And again, we're just looking at numbers, and numbers relate to data in some way, or data. So anyway, a lot of times you'll have this considered to be the X direction, and this is the Y direction. What the heck does that mean? It just means horizontal and vertical. You could call these whatever you wanted. You could call this T for time. You could call this, D for distance, whatever you want. It just depends on what kind of data you're looking at, how you're describing what you're seeing in the world or predicting, whatever. It could be money over time. It could be, whatever. Money over number of projects versus number of people, whatever you want. Population per square footage or, square acreage, whatever you want. Anyway, I'm just trying to hit home that there are reasons why you do this. So a lot of times you're given something like this. You'll say, okay, I've got 2 data points and they have a coordinate. Let's imagine that this is 5, this is 10. This is always 0, by the way. This is the origin. It's what we call 0, 0. And this is, in the coordinate system here, X and Y. So this is always, the first one's always the X, which means horizontal in our case. And the second one's always the vertical, which we're just labeling as Y. And so we take that and we're going to say, these are perfectly scaled the same way. So that 5 and 10. And so we go in here and, let's just say that this is roughly, I didn't draw it very well, but we'll just say that that's 3 horizontal, 1, 2, 3, boop, little tick mark. And we'll say that that's 3 vertical. I mean, look at it. It's really more like 2.5, right? But we're not going to get into that too much. And let's just say that this is 7 horizontal. And then over here, this is 5 vertical. Okay. And then we realize that there's a line between them. And in this case, I made it a line segment because it has a definite start and stop. It could keep going on. It could just go off in one direction, whatever. The important thing is that I want to know what this slope is. So you say, all right, let's make that a little more understandable. There we go. Boom. Totally are better programs for this, but this will serve. As we go through, now we can forget that we have 3, 3 if we wanted and 7, 5 if we just knew these differences here. The slope is really going to be the rise, which is the difference or the delta. That little triangle stands for delta. The difference in the vertical divided by the difference in the horizontal. Again, don't get so hung up on y and x. They're just variables that we use. I'm going to pull them here. So this represents the change in y and the change in x, assuming that we're going upwards. Because again, we're going from left to right, and we're going to have to climb, 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 climb. And the greater the change in the vertical and the less of a change in the horizontal means it's going to be steeper. It's going to be a harder job to do, right? Which means we're experiencing more change over whatever we're looking at here. So the change in the vertical, well, let's see. Here's the vertical. So 5 and 3 went from 3 up to 5, so it added 2. So that's a positive 2. The change in the horizontal, it went from 3 over to 7, so it added 4. Now, you might remember that, right? You can do number lines if you want. You can do subtraction, okay? But it added 4, so it was a positive 4 change. If it helps you to put a little plus sign out there, great. Just don't think that you're adding it into something else. So we take this idea that slope is... Oh, that looks horrible. I'll give myself some grace, right? Slope is rise over run. So that's going to be 2 was my rise over 4. Hey, 2/4, that's great. Well, that's 1/2. And I don't know, maybe you need to put it in the decimal. So you can say 0.5 or 0.5. And they're usually units here. So this would be like units of, I don't know, time. Well, units of time. So we'll just say like seconds. We'll just make this something. Doesn't have to be time. And maybe this is units of distance. So we'll say meters. And so if that was the case, then that would be meters per second. It can be whatever, right? It can be dollars per hour. Whatever it is, it's a rate. So if I had different dots here and it was steeper, that means I have a greater rate. If it's more shallow, I have a lower rate. Okay. So you can really take this pretty far, but let me show you. Let me show you another standard format that you'll probably see, and it just means exactly the same thing. You'll probably see slope defined this way. y2 minus y1 over x2 minus x1. Or y final minus y starting or initial or at time 0 or whatever. X final minus x initial. Guys, it's all the same thing. You can rewrite your stuff no matter what you want. As long as, the middle is usually okay for your teachers. As long as you end up in the format that they like, then you're usually good. And I'll tell you what, something that changed my life was in 8th grade. I was doing algebra, and my teacher said, David, I was having trouble. I really was. My teacher was like, David, I have no idea how you did this, but it consistently works for you, so I'm going to let you do it. And that changed my math identity. It changed the way that I look at myself as a doer of math. And so this is just an example where you can do what you want as long as the rules are consistently giving you the right result. So if you want to change these things, if you want to call this D and this C, go for it. Whatever makes sense to your brain, do it. Okay? There's a whole lot that we can do here with slope, but I'd say that is a good enough introduction. I do want to just tell you one other thing, though. When we define a line, zoop, we define a line. There we go. Yeah. Let's be real fancy, shall we? Let's just say we start from the origin. What does the word origin mean? It means place of beginning, right? Beginning point. You can start from the origin, but you don't always do that. Sometimes, I'm telling you, there are better tools for this. Sometimes you start from here, and sometimes the line goes completely on and it covers through. That's okay too. Got it. Zoop. Hey, nothing in the comments about hating on MS Paint. Anyway, sometimes you have what they call y-intercept, which means you're literally cutting through that vertical axis. So let's just say that that's 2. Okay. So that's the y-intercept. And this is the slope, right? You can't really show it there, but you know that this has a slope. And so we usually write it along the line. And the slope is usually written with m. It's a variable m, and actually it'd be a constant. So it's the constant m, constant for that line. And we know that we deal with this in terms of x and in terms of y. And so here's something that you're going to see all the time. You might as well memorize it. Y equals mx plus b. I put a little dot in there because I like to remember that they're multiplied. So there's the constant for the line that you're dealing with. That's the slope. This is x, this is y. And it literally means that for any set of points here along the line that's defined by this equation, it's an equation because it has an equal sign. Learned that the hard way in the past. Any point along this line is going to be ruled by this equation. Or I guess you could say the other way, this equation describes any point along this line. Okay, or it's going to match this. It's going to be bounded by this, even if you're down here. Okay. So this b over here, if it started at the origin, then it intercepted y at 0. So b usually it would just go away. It would be 0, plus 0. But here we see it's plus 2. So if I did this, let's just say I know the slope is, I don't know, let's just find one real quick. Let's see if this is 2. Might as well give you an extra example there. If that's 2, and I know that this is, let's see, 2, 4, that looks like a 5 to me. That looks like that's about 5. So that's probably about, we'll just fudge it and say it's 4. It's pretty close. I'm going to make it a little more understandable. Let's say that that's 4. Right? You're allowed to make as many hash marks as you want in there. So that means that this little point here, let's change the color. This little point here, it's at, there's no room for it, right? Well, look, this is the origin. So x is 0 here. We're lined perfectly up vertically with it. So that's 0.02. I'm staying positive here, right? Hey, stay positive. I'm staying positive in the horizontal and the vertical, but you can go negative in the horizontal. You can go negative in the vertical. We can get into that some other time. Anyway, this little point right here, Hey, draw an arrow if you want. That little point right there is over 5 on our coordinate plane here, and it's up 4. So let's find the slope. How about you pause the video and try to figure it out? Okay, go ahead. Pause it and then start it again because I want to see you back here. Okay, slope, look, I'm using the M, is the change in y over the change in x, the change in the vertical over the change in the horizontal. Yep, and you can just do this however you want. You can think of it as I'm in the y, I'm at 4, I started at 2, so it's a 2 difference, or you can put y2 minus y1, that's fine too. And the x is an easy one, right? Because you started at 0, you ended up over here at 5, and so I went over positive 5, and that's 2/5. Now 2/5 I know is going to be 4/10, all right? A little trick there, and 4/10 is equal to 0.4, okay? Circle the answer. Anyway, that's the slope. We don't have units, but we could put them there if we had them on the graph. And we could even title this graph. Wouldn't that be great? Y versus X, whatever that is. Okay, so there's the slope. And so in this case, we can make a general form for this equation. Y equals 0.4 X plus, what the heck is B? Well, it's that y-intercept. In this case, it's 2. And so this is the general form for the equation of that line. And that means that you can actually identify any single point along here. Incidentally, if you know the value of x, let's just say like this is 7. So you want to find out for this point what the value of y is. Ooh, it looks like if I drew this really well, it'd be a little more than 5. You can plug and chug. So take this value here. We know we found slope, so let's just knock that bugger out. Zoop. Let's do our work over here. Hey, little tip for you, pro tip. Get yourself a 4-color pen. Really good for math, taking notes and doing your homework and things like that. So we want to find what the y value is, what the vertical value is here. It has value to us. Okay. So 0.4 times, we wanted to find it when x is at 7. Maybe this is number of days that have passed, or it's number of hours that we worked, or whatever. Number of minutes that we've run. So 0.4 times 7, okay, and then plus 2. All right, you guys know how to multiply these out. Well, 7 times 4 is going to be 28, but there's a decimal in there, so it becomes 2.8. Okay, plus 2, that equals 4.8. 4.8 watts? Well, we don't know because it was unitless. And that's pretty good. So I didn't draw it to scale, but you can see it's close to 5, and so that makes sense. That's about it. If you need more examples, if you want to talk about negatives, just drop something in the comment. Would be happy to help. Okay, don't forget to like and subscribe, folks. Give me some more ideas. You have specific questions? No problem. Let me know.